Okay, let's dive in. So picture this. Kesser's helping his Oma, with the dishes one evening. Pretty standard stuff.
Right, just the usual cleanup.
Exactly. But then something kind of weird happens. He adds some dish soap to a bowl that had red cabbage in it.
Okay.
And the water, it just starts changing color, like completely out of the blue. Or, well, into the blue, maybe.
Huh, right. And that's not just some random kitchen magic, is it?
No, not at all. It's actually, proper science happening right there in the sink. And Kesser, he got curious.
Naturally. You see something like that, you want to know why.
Yeah. So the next day, in his class, Nature and Innovation with Professor Hendricks, he asks about it. He wanted to understand that color shift.
A perfect question for that class, I'd imagine.
Totally. And that's what we're getting into today, the science behind why red cabbage does that and how you can even use that property yourself.
Cool. So Professor Hendricks likely started with the basics, right? The whole pH thing.
Yep. Introduce the concept of pH first. Basically how acidic or alkaline something is.
That scale, yeah. Low numbers for acid, high for alkaline or basic, and neutral around 7.
Exactly, like pure water being neutral. And Professor Hendricks explained that red cabbage has this special pigment in it.
Ah, yes, anthocyanin. Bit of a mouthful.
It is, but the key thing, the really cool part, is what this anthocyanin stuff does.
It's sensitive to pH, isn't it? That's the secret.
Bingo! It acts like a natural pH indicator, almost like a tiny spy, changing its colors depending on the environment.
So it changes appearance based on whether it's in an acid or a base.
Right. So let's get specific. If it hits an acid, say vinegar, lemon juice, pH less than 7, what happens? What color are we talking?
Well, in acidic conditions, the anthocyanin molecule kind of shifts its shape, chemically speaking.
Okay.
And that change affects how it bounces light back to our eyes. So what we end up seeing is red or maybe pink.
Red or pink for acids. Got it. So what about the flip side? Bases, like that dish soap Kesser used, with a pH over 7.
Ah, yeah. In a basic environment, the molecule changes differently again.
Leading to different colors.
Totally different. Instead of reds, you're looking at blues, greens, sometimes even a yellowish color if it's strongly basic.
Wow, quite the range. Blue, green, yellow for bases.
Yeah.
Okay. What about just like plain water? Neutral pH 7.
In pure neutral water, it tends to stay more in its sort of natural purplish blue state.
Okay.
But, and this is important, tap water often isn't perfectly neutral, is it?
Oh, right. Minerals and stuff?
Exactly. Dissolved minerals can make tap water slightly basic, slightly alkaline.
So just rinsing red cabbage under the tap might give it a bit of a bluish or greenish look anyway, even before soap.
Precisely. You might see a subtle shift just from the water itself.
Huh. Okay, that makes sense.
And that ties right back to Kesser's dish bowl, doesn't it?
Yeah. The dish soap is basic.
Generally, yes.
So when he added it, the leftover cabbage stuff, the anthocyanin in the water, reacted to the base.
And bang, shifted towards those blue or green colors he saw. Mystery solved.
Professor Hendricks really laid it out clearly. And it seems like it doesn't hugely matter which red cabbage. Our notes mention red-pointed cabbage specifically. Red spidskal, I think.
Yeah, red-pointed cabbage or just regular round red cabbage, they both have the key ingredient.
The anthocyanins.
They both contain those pigments. So whichever one you've got, chop it up, add some acid or base, and you'll see those color changes. It's all about the pigment.
Cool. So Kesser learns all this, and his brain starts ticking, right? He doesn't just go, huh, interesting.
No, it sounds like he wanted to do something with it. Practical application.
Exactly. He decided to make his own pH indicator using some leftover red-pointed cabbage he had.
Nice. And it's actually pretty simple to do, something folks could try at home. What were the steps?
Well, first he chopped up the cabbage, just, roughly.
Okay, standard prep.
Then he poured boiling demineralized water over it.
Ah, demineralized. That's a key detail. Why specifically that?
Good question. You mentioned tap water isn't always neutral, right?
Yeah, the minerals can affect its pH.
So using demineralized water means you're starting with a truly neutral base, pH 7.
Right, so any color change you see later is definitely from the substance you're testing, not from the water messing things up.
Smart.
Very smart. Okay, so he's got the chopped cabbage soaking in the hot demineralized water. Then what?
Then you just let it sit. Steep it, basically, like making tea.
Okay.
Until the water pulls out those anthocyanin pigments and turns a nice, rich, bluish color.
Once it's colored.
You just filter out the cabbage bits, strain it. What you're left with is your indicator liquid, ready to go.
Awesome. A bottle of homemade pH tester? How did he actually use it then? to test things.
Super simple. You just add a little bit of this blue indicator liquid to whatever you want to test.
Like household stuff.
Yeah, exactly. A bit of vinegar, maybe some baking soda mixed with water, lemon juice. Maybe even, carefully, some diluted cleaners.
Okay. And you just watch the color.
You just watch the color change. Or not change, if it's neutral.
Right. So we have our mental cheat sheet. Red or pink means acid.
Blue or purple, pretty much neutral.
Or close to it, yeah.
And green or yellow tells you it's a base.
That's the essence of it. It's a fantastic visual way to explore acids and bases you find every day.
Really is. Now, Kesser, being Kesser, he made a fair bit of this stuff, right? This blue liquid.
Seems like it. And he ran into a practical issue. How to store it. You don't want it going off or just having a big bottle sitting around.
So what did he come up with? He had some clever ideas, apparently.
He did. The first one was pretty neat for long-term storage. He poured some of the indicator liquid into ice cube trays.
No way!
Yeah, and froze them. So he ended up with indicator ice cubes.
Indicator ice cubes, that's brilliant. Just pop one out when you need it.
Exactly. Let it thaw, you've got a small amount ready to use. Super practical way to keep it for ages.
I love that. Okay, so that's one idea, but he didn't stop there.
Nope. He was also thinking ahead, about their plans, him and Steen, to grow blueberries for Steen's mother.
Oh, yeah. And blueberries like acidic soil, don't they?
They definitely do. So testing soil pH is pretty important for them.
Right. But carrying a bottle of liquid indicator or frozen cubes out to the garden or, to a customer's place, maybe not ideal.
Not the most convenient, no. Especially if they're visiting someone like Tante Gran, Aunt Green, to check her soil.
Tante Green. Okay.
So Kesser had another idea. He took some coffee filters.
Regular coffee filters?
Yep. And soaked them in the indicator liquid. Then let them dry.
Wait, so he made his own pH paper, like litmus strips?
Essentially, yes. Homemade indicator paper strips.
That is so resourceful.
Wow, isn't it? So now they have these portable strips. They can take them anywhere.
How would they use them for soil? Just stick it in the ground?
Probably mix a little soil with some neutral water, demineralized. Ideally make a little slurry, then dip the paper in. Or dab the slurry onto the paper.
And the paper changes color depending on the soil's pH.
Exactly. Way easier to carry around and use on the spot.
Imagine showing up at Tante Grun's, whipping out your homemade pH paper. Pretty impressive.
Shows you know your stuff, right? And you're prepared. It's a fantastic example of taking a scientific principle and making it really practical.
It really is. Shows how just a little understanding can spark some great, useful ideas. Okay, so let's just quickly pull the main threads together for everyone listening.
Good idea.
We started with Kesser seeing that weird color change in the dishwater. Just a simple observation.
Which led to Professor Hendricks explaining the science. Red cabbage has anthocyanins.
Right, those pigments that act as natural pH indicators, turning reddish in acids.
And blue, green, or yellow in bases.
Then we saw Kesser's ingenuity, taking that knowledge and running with it.
Making his own indicator liquid first.
And then the really clever storage and application ideas, the indicator ice cubes.
Great for keeping it long term.
And the homemade indicator paper from coffee filters, super portable for testing soil pH, like for their blueberry plants, or visiting Tante Gren.
It really highlights how Kesser didn't just learn a fact, he engaged with it, saw a need, and innovated solutions. That's learning in action.
Absolutely. And it's a great reminder that science isn't just for labs, it's everywhere, even in a head of cabbage or a dirty bowl.
Hopefully folks listening might look at red cabbage a bit differently now, appreciate its hidden talents.
Definitely. And maybe it gets you thinking.
Yeah, that's a good point. Thinking about what else is around you, in your kitchen, in your garden. What other everyday plants or natural things have these kinds of hidden properties?
Like other potential indicators, maybe. Or other reactions we just don't notice.
Exactly. What other secrets are just sitting there waiting for someone with a bit of curiosity that Kesser-like spark to observe them, ask why, and maybe even figure out how to use them? There's probably more out there than we think.